Good example once again. We just looked at lecture 1 of unit number 5. Let us now look at lecture number 2 of unit number 5. So this lecture would cover irrigation and the basic design that goes to setting up irrigation designs and other hydraulic designs. I'll not be touching on other hydraulic designs such as dams and all, but I'll be posting reading materials for the other hydraulic designs. You can go through the reading materials and see which ones are efficient towards conservation of water. But I'll be talking on one of the famously used traditional water harvesting system known as Qanat system, which is practiced in desert areas and some Middle East countries like Iran, Afghanistan and all. So let us look at the irrigation system and other hydraulic designs. Irrigation systems are like we just saw in the unit number 4 and lecture number 1 of unit number 5, that there are 3 kinds of irrigation system famously or most commonly used. One is surface irrigation, that we talked mainly as flood irrigation, which is also one of the type of surface irrigation. Second one is seepage, and the other one is furrow. So making furrows and irrigating that area. That's how furrow irrigation works. So that's also one of the kinds of surface irrigation. The other one is overhead irrigation. The example that we saw was sprinkler system. The third one is drip irrigation, and these are the 3 majorly or commonly used irrigation system. The main purpose of irrigation is number 1 is that we need to avoid water stress in the crop. Sometimes with the lack of proper water supply to the crops, the crops get stressed from the lack of water. So we want to prevent that water stress. We want to provide, or we want to supply water for that crops to reduce itself from the stress. Second one is that we want to avoid excessive application of water, because like we saw that it's going to lead towards the nutrient leaching, as well as deficit condition of oxygen, and it may cause different diseases and lead to decay of the root. So we do not want to either cause a stress through limited amount of water in the soil for the plants, neither we want to create an environment where we have got excess water in the soil. So these are the main 2 things that we need to consider before looking at the irrigation. When we're talking about irrigation, there are few terminologies that we need to look at, but from few, there are 2 main terminologies that we need to take care of. The first one is irrigation requirement. So irrigation requirement is basically a broad amount of water required for us to apply to the crop. So amount of water that needs to be applied to the crop is called as irrigation requirement. The second terminology is called as water use efficiency, or commonly called as AE, application efficiency. So this is what this is the small fraction, or the small amount of water that is actually available to the plant from the irrigation requirement. So if you are applying, or like if you are using 5 liters of bucket of water and you are applying to the crops, out of 5 liters, the crop may be accessing, or the crop may be having availability of only 1 liter. So 4 liters are getting wasted, and that 1 liter that is available to the plant is what application efficiency is all about. So the fraction of the water applied or the irrigation requirement that is available to the plant. So fraction of water that is available to the plant is what application efficiency is all about. And application efficiency of surface irrigation system is very low, 20 to 70%. So only around 20% is actually being available for the plants, and rest like 80% is actually wasted. Or like if you're looking at the higher margin, it's just 70% that the plants are actually availing. And if you look at the overhead sprinkler systems, like the overhead systems, the application efficiency goes to 60 to 80%. So that means we have less window of wastage of water system. And drip irrigation system, 80 to 95% is what application efficiency of the system is all about. So application efficiency is the water that's being available from the water that's being applied to the crop or to that area. And the direction that you move from surface irrigation to the drip irrigation, higher the application efficiency that your crops may get. So it's all about now looking at application efficiency. So when we are choosing the best irrigation system, we need to choose an irrigation system that has higher application efficiency. And the main goal of water management now, the main goal of irrigation through to address the water management is to apply required amount of water at appropriate time. And again, applying too little water when it is needed can lead to plant stress and potentially lower the yield. And it's very important whenever plant needs. It's very important for us to apply water whenever plant needs. And if you're applying too little water, that's when the plant will have potentially dangerous stress, and it will again lower the yield. If you're looking at cabbage, let's say, the kind of size and the freshness, the quality of cabbage that you'll be getting from the agriculture will be lower in quality. Again, if you look at the year, this is looking at the first month, second month, third month to the 12th month. Towards the beginning of the seasons, when plants are growing, when plants have when the plants are flowering, when plants have just given fruits, that's the time when you really want to take care of the plants, take care of the crops, because towards the early season, if you're not taking care of your plants, it's going to delay the plant maturity and reduce their production, because plants are yet to give flowers and fruits, and these deficits during the early seasons can lead to immaturity. But however, it's not just during the early seasons. It has to be uniform. The watering of the crops or the irrigation of the crops has to be uniform throughout the period of the plant. Even during the late season, if you feel that, yes, now my apples are grown well, I do not have to take care about with the watering of this apple and all. If you just leave it like that, or my cabbages are doing well and I do not have to now water the cabbages, towards the late season, if you just think like that, the kind of quality that you'll be getting, the kind of quality of cabbage that you'll be getting will be very poor if you are neglecting the watering of those crops during the late season. So I think it's very important even to water during late seasons like 9th, 10th, 11th months and all. So it's very important to water even during those stages. And please try to again avoid the wastage of water. So if you just look at this diagram or this graph, these arrows are where we have to apply irrigation systems. So these are the dips. So water is something that's not going to be very consistent in amount, consistent in quantity in the soil. So it will just fluctuate up and down, up and down, up and down, up and down. So whenever there is dip, you apply the irrigation, it again is going to go up. This water is going to be consumed by the plants. Again, it's going to come down. Again, give or again supply water through irrigation system. Again goes up. Again comes down. And during the seasons like rainfall events, it's really going to go up. And again, that's the area of safe irrigation zone. That's when the water has gone very up, and water in the soil has gone very up, and that's the area where you do not need to irrigate. I think that's during the summer seasons or the monsoon seasons. So again, after the summer seasons, again the dip comes very down, and that's when you need to again irrigate the soil. So this is how irrigation really works. So there are three kinds of irrigation systems. I'll be just showing a few video clips of what these irrigation systems look like. I know you all have seen. This is sprinkler system where you basically have sprinklers, overhead sprinklers, and this is drip irrigation system where you have only those areas where you need water comes out. But this exactly cannot be drip irrigation system because water drops are not coming out, but huge quantity of water is coming out. So this can be a surface irrigation system, specifically a furrow irrigation system, because you can see that there are furrows or dikes between those plants. Let us just briefly look at how to design a irrigation systems, like any irrigation system, like let's say sprinkler system or a drip system or surface irrigation system. So let's just look at one of those. Let's look at overhead irrigation system.
Before placing an irrigation system, it is a good idea to evaluate the path that the water pipes will follow and consider whether and where to place the sprinklers. Remember that each sprinkler can water all around it or only in a very specific angle you have set. Look at the garden and draw the area on a piece of paper with the places of trees and shrubs. Then mark the tubing with the path that the water will have to take to reach the majority of the garden, trying to avoid concrete paths or other barriers of this kind, which, if they have to be on the path of the pipeline of the irrigation system, will have to be crossed appropriately. After you have drawn the path of the pipeline, you should consider the placement of sprinklers, checking how much area the sprinklers you have chosen can water, and making sure to cover all the ground, leaving no spaces. Try to draw on your project the areas that will be wet by the sprinklers and if necessary, organise it so that some areas of watering overlap, so as to cover all the ground.
I hope that you must have got some idea from here. Again, there's another 2 to 3 minutes video clip that is also regarding the overhead irrigation system. That should make you have a better concept of how to design irrigation system. So let's again look at this one.
Accurately estimating a job is paramount for any irrigation landscape contractor. Underbidding a system could mean lost profits, while overbidding means you might not get the job to begin with. One key factor in estimating is to know how many zones it will take to irrigate a property. To do this, you need 3 pieces of information. One is the area of the property that you're irrigating. The second one is the precipitation rate of the heads going into the property. And the last piece you need to know is how much water you have available at the source. There's a couple of ways to get the area of a property. One is for you to physically go out there and measure the property, but another way is for you to use websites like goilon.com, who uses tools and satellite imagery to give you an accurate area calculation without you ever stepping foot out on the job site. The second piece of information you need is the precipitation rate of the heads you like to use. Now, thankfully, the manufacturers give us this information in their catalogs. So all you need to do is go inside, find the nozzle, and move across and find the precipitation rate for a given head spacing and pressure. Once you have the precipitation rate and the area, we can put it into a formula that will give us the total flow for that system. Once we have that value, we can divide it by the available water at the source, and that will tell us how many zones it will take to irrigate that property. Here's an example. The area of our property is 40,000 square feet. The precipitation rate of the head we're going to use is 0.5 inches per hour. So what you're going to do is take the 40,000 square feet, multiply it by the 0.5 inches per hour. You're going to take the result of that and divide it by 96.3. 96.3 is a conversion that will get our units into gallons per minute. When we do this math, the result will be 208 gallons per minute. The last bit of information we need is the available water at the source. In our example, we're going to have 18 gallons a minute. Now take the 208 total gallons a minute and divide it by the 18 gallons a minute of the source. And that will give us the total number of zones, which is 12. Now, that is our starting point. It's going to take a minimum of 12 zones to irrigate this.
So yes, this is how we design irrigation systems. Drip irrigation system may require a little bit more work and a little bit more calculation, as well as it should be having more financial implication compared to surface irrigation system and overhead irrigation system. So basically, you need lots of calculation in setting up or designing irrigation system. I'll be not looking at other hydraulic system. I'll be posting the notes based on other hydraulic system. What are other hydraulic systems that are commonly used around the world to manage water? So I'll be posting in VLE. One very interesting thing that I have found looking at the materials to find out other hydraulic system was a very traditional yet very interesting hydraulic system called as Qanat system. So this is practiced usually in places like where water is quite scarce, places like in desert area, specifically in countries like Afghanistan, Iran, and Middle East countries. These are quite commonly practiced, and it has been practiced since 2,700 years back. And let us look at this, how it works. So there's a very lengthy video on this one, which I do not want to post right now with the video presentation over here, but I would like to certainly give it to you through VLE, or if it is not working through VLE, I would like to give it to you when you come back to the college. So here it is about Qanat system. So one of the traditionally or one of the historically used underground water irrigation systems. So this is combination of irrigation system as well as underground water system. So what it does is basically the underground water is being tapped, and that tapped water is used for irrigation system. In in desert areas where we do not have a very good amount of surface water, and when we again do not have a very clear clue or idea of where our groundwater system is located, the people who are practicing this Qanat system, they have a very clear conscience that the groundwater system is located in that particular place, and that groundwater system can be tapped and brought to the area where we have got settlement. So basically, it has lots of connections of wells. You can find around you can find a length of 7 kilometers tunnel connected through a series of wells. I'll be explaining this in this slide. So you have around few kilometers of tunnel dug all the way from the point where we can see the surface, and these blue lines over here are basically the groundwater. And Qanat system is basically a system where groundwater is being connected by a series of wells, and these wells are again an access point for people who are living around in this area. So this area, people will come over here, and they will pump this well, and they will get access to water. Again, advantage thing about this system is that these wells, though they are connected to the main outlet over here, the water can flow to the lower regions or the people who are away from the groundwater or this area or the well. So not only used by people who can access wells, but they can also be used or accessed by people who are living far away from the underground system. So this can flow out to a very far away, like a few kilometers away, and the people can access to this wells. So from space, it looks like this. So these are basically the wells. These are basically the wells, and these are the settlements. So in desert area, if you do not have water, you do not have crops, and you do not have plantations going on. But because of this ingenuity, series of wells are being connected, and these wells underneath, they should be having a tunnel, and this tunnel leads to water till here. This point is the point that is just over here, which is intersecting with the surface, and from this area water flows, surface water flows, and this is being used for drinking, irrigation, and other purposes in these settlements. Again, this is another region where Qanat system has been working. So these are again well brought. The groundwater connection must be somewhere here, and these are being connected with wells, and around here the surface water has come out, and this settlement is getting access. So we can also see one area here. So in this region there are one Qanat here, one Qanat system over here. We can also see one Qanat system over here. So these are the Qanat systems. So around 3 in this area. This is again another Qanat system shown through the speeds. So quite interesting to look at. One of the interesting facts of Qanat system that I just found through internet is that the oldest and longest Qanat system is located in a place called Qanat city of Iran, and the mother well, or the first deepest well, is about 360-meter deep. It's quite deep. Then the length of the length of the tunnel, or that Qanat main tunnel, is about 45. So Qanat system is also known by the local dialect Karizes. So Karizes and Qanats are basically synonyms, so do not get confused. So the Karizes tunnel or the Qanat tunnels are of the oldest and longest Qanat in Qanat is around 45 kilometers, and this is still alive, this is still working, and it is around 2700 years old, and it has been providing drinking facilities and agricultural water for about 40,000 people till date. In Iran itself, there are 50,000 Karizes, and each Kariz has an average length of 7 kilometers. So you can say this is a 7, this is one is 7, 7, 7. But if you are totaling all the 50,000 Karizes having average length of 7 kilometers, you are getting around 350,000 kilometers of Karizes in Iran. So I just wanted to bring this issue here, just to say that this is the height of the Karizes or Qanat construction in the world. And if you just look at the total length of the Karizes in Iran, it's around 350,000 kilometers. That's exactly, or that's approximately the distance from Earth to the Moon. So that's the length of the Karizes. In Afghanistan, these dots are basically the areas where Qanat or Karizes are located. So you can see huge number of provinces have been covered by the Kariz systems. In Afghanistan alone, the colored ones are the provinces that are being covered by the Karizes or Qanats. So this is one of the most traditional water harvesting irrigation system used by the people, specifically in the desert area. So there are again lots of hydraulic systems that are being used, but this one is quite interesting to look at. So that's it. So other hydraulic system I'll be posting in VLE. You can go through yourself. This is mainly regarding the dams and other reservoirs. Thank you so much.